Hey guys, today we're looking at section 2.1. So if you go to your textbook, your online textbook, you can follow along and you will now be in module 2, 2.1. So we're still in the first unit, but now we're in module 2, which is the second half of the unit. So today we're going to look at solve quadratic equations by taking the square roots. Alright, so a quadratic equation, every quadratic equation has x squared or something squared. The fact that this is a squared term means that this is a quadratic equation. So a linear equation is something to the first power, a quadratic is something to the second power. So the equation has to have something to the second power in order to be called a quadratic equation. Alright, so we're going to look at how to solve a quadratic equation. So what I'm going to do is first pull up my pencil here and see if we can just look at solving a quadratic equation. And then we'll go through the little boxes and do the drop down. So it says 6x squared minus 5 equals 0. And anytime we have a quadratic equation or any equation, we're trying to solve for the unknown. So the first thing we're going to do is add 5 to both sides. So we're going to have 6x squared is equal to 5. And then we have to get rid of this 6, so we have to divide because that's multiplication. So to undo multiplication, we divide. And we have x squared equals 5 over 6. Now, x squared, the inverse, or what will undo something squared, is the square root. So we're going to take the square root of both sides. So we're going to have x equals, and when we take the square root of an unknown, we don't know if that was positive or negative. So we're going to have plus or minus the square root of 5 over 6. And then you have to rationalize the denominator. So we have x equals plus or minus the square root of 5 over the square root of 6. And to rationalize your denominator, you have to multiply by whatever's on the denominator. Something squared, so a square root squared, will undo the square root symbol because the square root and something squared cancels. So this is going to be 5 times 6 is 30, so we still have the square root of 30 on top. And then 6 times 6 is 36, and the square root of 36 is just 6. So like I said, this is the square root of 6 squared, because anything times itself is that squared, and that means the squared and the square root cancel, and that's why we have just 6 on the bottom. Alright, so now we can look at what needs to go in our drop-down box. Alright, so the first thing we did was add 5 to both sides. So we're going to take 6x squared and drop it here. And then we divided by 6. So take this one and drop it in the next spot. And then we took the square root of both sides. Alright, and then we're going to look at the quotient property. Quotient just means division. So this is division. And then we're going to rationalize our denominator by multiplying top and bottom by the same thing. If you multiply top and bottom by the same thing, you're just multiplying by 1. And then you're going to get your final answer of x equals plus or minus the square root of 30 over 6. So if you remember, that's exactly like what I just did to the side there. So we can check to see that we did those steps correctly. All right, so when you're solving a quadratic equation by taking the square root, then you're just solving for x like we've done in the past. All right, it says use the table, evaluate the expression on each side of the equation using the values of x and x between -1 and 1. All right, so if you wonder, this is 6x squared, and this is 5, and that's just coming from our equation up here. So we have 6x squared, and then when we added 5 to the other side, we have just 5 in this column. All right, so 5 is a number. It can't change, so we know that we can just drop a 5 in here, and that's it. All right, now we want to know what this is when we substitute these values in for x. So if you take your calculator, you can do 6 times -0.8 squared, and that gives us 3.84. So 3.84 goes here. And then we're going to do the same thing for 0.7. So we're going to have 6 times 0.7 squared, and that's going to be 2.94. And then we need to fill in the last one, 0.9. So we've got, again, this equation. We're just substituting the numbers in for x. So we got 6 times 0.9 squared. And that one's going to be 4.86. All right, on the next question, it says select the correct answer to complete the sentence. The values of the two expressions are equal when x is approximately plus or minus. And if you look here, it's going to say approximately 0.9. All right, so see, it's not exact, but it's getting close to 0.9. It's getting close to equaling 5. So 4.86 is not exactly 5, but we're getting closer to that point. And if you see the squiggly line here, that just means approximate. It's getting close to. So let's check that. All right. Now it says a student wants to find the radius of a frisbee whose area is 110 square inches. The student knows that the equation for the area of a circle is pi r squared. Use this equation to find the radius of the frisbee in inches. All right, write a verbal model. Let area equal the or let A times R equal the area of a circle and R equal the radius of the circle. All right, so the equation here, area of the circle in square inches equals pi times radius squared. Okay, so write an equation. All we're going to do is substitute the 110 inches, which is what they give us for the frisbee, the radius of the frisbee, whose area is 110. So we're going to put that in for area, because it says the area is. All right, so if the area is that means we're solving for r. So 110 equals pi r squared. First thing we do is divide by pi, because we're trying to get r by itself. So that is division. All right, after we divide, we are going to take the square root of both sides because we're trying to get r by itself. So that's going to be this one here. All right, and then to rationalize the denominator, again, we multiply top and bottom by pi. So here this shows that we multiply top and bottom by pi. And then the last thing, all right, I believe they lost the pi. This should have a pi right here. So just so you know, whoops, sorry about that. All right, this should actually be 110 pi over the square root of pi equals r. All right. And is that the last question? Let's see. All right, there's one more. Since the radius of an object cannot be negative, the radius of the frisbee is... All right, so let's go back up here and see. All right, so it should be the plus or minus 110 pi over pi which is about 5.9. And you can plug this in your calculator and see as well. Let me see if I can find my calculator again. All right, so if you do the square root, so we're going to do square root of 110, and then pi is right here, and then hit enter, and then divide that answer by pi. That gives you 5.9. So the square root of 110 pi divided by pi equals 5.9. And again, that's just more confirmation that they have left off a pi in this last equation here. All right, that's all for this lesson. If you have any questions, let me know.